Welcome to ATCA's Speakers Forum Series webinars, where we discuss poignant topics facing the ATM industry. Today, we are joined by GDIT. We will discuss ATM in the cloud and how it offers modern tools and processes to maximize cloud value. Michael Hawthorne, Business Development Director with GDIT, will lead panelists Lane Lesniewski, Cloud Services Director for GDIT, and Samir Ramchandani, Strategic Alliances and Cloud Strategy for GDIT. Take it away, Michael.
Thank you, Rutger. Good morning, everybody. I'm Mike Hawthorne, Business Development Director here at GDIT. With me today are Lane Lesniewski, our Cloud Services Program Director, and Samir Ramchandani, who leads our Strategic Alliances and Cloud Strategy. GDIT has been supporting the FAA and the aviation industry, introducing new technologies and capabilities for over 50 years. From the inception of flight data processing and evolution to en route automation modernization, implementation of traffic flow management, transition to digital voice communications, and introduction of cloud services, GDIT was there. Today we're going to discuss cloud computing, what it is and why we believe it is very well suited to provide mission essential and potentially mission critical capabilities in our national airspace system. The need to modernize the NAS is not in question, nor is the fact that doing so is not easy in today's budgetary environment. One approach to this difficult task includes implementing a services-based architecture that facilitates quicker development, quicker delivery of new capabilities, with cloud computing playing a major and pivotal role. When implemented properly and appropriately, cloud allows for improved scalability, security, resiliency, and faster deployment. To move forward into this new world, stakeholders require a fact-based common understanding of the benefits and the risks associated with cloud and its inherent tools and processes to perform engineering, operational and safety analyses, and to make informed decisions. Our goal today is to inform our community of the benefits of cloud and how cloud actually mitigates some of the well-founded concerns we all have. Let's get started. So Lane, walk us through cloud computing, what it means, and how it's different perhaps than the more traditional owned and operated infrastructure.
So cloud computing at its highest levels is on-demand resources, in particular compute, storage, and networking. And it's divided up amongst three areas that people would hear or know. That is, we have public, we have private, and we have a hybrid. Public is when someone else, like a cloud service provider, provides the underlying infrastructure for you. Private would be where you as a company or agency actually host that yourselves. And then a hybrid is a combination of the two, where you have some resources on premise and then some resources with a cloud service provider or someone else. The benefit to those is that everything is on demand, and so you're not having to make those investments up front. A couple of other things that are worth mentioning about cloud computing is there's a few terms: infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service is just that. It's your basic compute and storage tied together with a networking. Software as a service is things such as applications. Most people are familiar with your Microsoft suite of products, Office, and those sorts of things. And then a platform as a service is a combination kind of software and the infrastructure, whereas a little bit more of the infrastructure is provided along with some basic applications to it.
Awesome, thank you. Now, Samir, can you talk to us about some of the primary processes and tools that enable cloud computing, and talk about maybe some of the benefits when we compare them with the current monolith and waterfall type programs?
So if you look at the traditional monolith and the waterfall programs, they focus on a single code base, on a single sort of architecture that's not so dynamic, that's not so agile. As you mentioned in your intro, Michael, cloud really brings that microservices, that service-based architecture, which is more focused on capabilities and delivering services to the mission. And what that really means is a services-based approach that is taken where individual services or components are developed by separate teams. Those teams collaborate extremely well and close together to bring those services, yet the individual services communicate with each other through APIs. What this really offers the agency is the elasticity, is the flexibility, is the reducing the time to market. The other aspect is also containers. So cloud also enables organizations to bring code through containers. A container, just like the name suggests, is a single unit that has software and deployment files. So you could be deploying a container anywhere, whether it's your laptop or on the cloud.
Awesome. Thank you very much. And I think we're all level set now with cloud and terminology and so forth. So let's get into some of the things that we know folks are worried about. Let's start with data privacy and security. Lane, how does cloud deal with those things?
So from a security perspective, security is just as important in the cloud as it is on-prem. The thing about using cloud technologies in a security perspective is that with using a public cloud or even a government cloud, the agencies have the security in mind with the actual cloud service provider. So we talk about FedRAMP and some of the government agencies, the NIST standards and things of that nature. When you're using a cloud service provider, that security is actually brought to you from the get-go. One less thing that the agencies and others have to actually rely on and worry about architecting themselves. That's a big benefit as it relates to the security aspects of the cloud stuff.
Very good. Samir, you have anything to add on data privacy or security?
I'd just like to add to what Lane just mentioned is that security is also a shared model. It is, and it's very important to understand and also respect that security is a shared responsibility. And when I mean shared responsibility, it's a shared responsibility between the cloud service provider, the customer, and also the integrator. So across those three entities, security is a shared responsibility where each one has their own controls, and the government has their compliance standards, but then the cloud service provider also provides native security capabilities so that they could be adopted throughout the life cycle.
Okay, to just pull the thread on that a little bit, how do the parties that are sharing responsibility generally interact with one another during the process?
So again, it comes back to the requirements, but essentially you would hope that using my analogy of the microservices architecture, there's close collaboration across those teams. You're delivering capabilities and services in cloud in an agile manner, which means daily, hourly, very rapid collaboration across all entities involved, not just to understand requirements, but also to make sure that those compliance needs that the agency dictates are being met and also being fulfilled.
Great, thank you very much for that. So let's talk about the various abilities, the availability, reliability, resiliency, disaster recovery. How does cloud enable us to meet or exceed the stringent requirements that the aviation industry demands? Lane?
Yeah, so actually, when we talked about the different types of clouds, public being one of them, public makes it easier from an agency perspective or a company perspective because that's kind of the sole purpose of the cloud service providers is to make sure that they have that underlying infrastructure needed. From a consumer perspective, we don't have to worry about so much, do I have enough, did I buy enough infrastructure to support my needs? It's pretty much on demand. You can use it's almost unlimited, if you will, when we come to think of it. And the nice thing about cloud is that because it is on demand and the capacity is there, from an application specificity, you can actually do things such as auto scaling. You can do things like reservations and such, so that at times of need, you can actually increase the infrastructure, whether that's virtual machines, containers, or other sorts. And then in times where it's lower, you can actually lower those and then cut your costs and help kind of save money versus whereas in the old days, you actually had to buy infrastructure, and whether you use the full capacity or not, that money is spent.
Mm-hmm. So that gets to, use the term on demand multiple times, that gets to the availability piece. We talk a little bit about the reliability, the resiliency piece, the recovery piece. Samir, you want to touch on that a little bit?
Yeah, Mike. Cloud is essentially close to 100% available, and that goes with a lot of nuances. Really comes back to your service level objectives for your organization, which also lead or feed into the SLAs, the service level agreements. But essentially, you could throttle cloud and services to your needs through those objectives and those service level agreements, so to speak. But each cloud has their own connectivity that provide you that resiliency, that provide you that availability. AWS has their direct connect, which is essentially a direct line into their cloud services from your data center or from your on-premises infrastructure. In the same way, Microsoft has their Express route and Google has Interconnect. So these are very mature services that have been around for over a decade or even more that provide you that resiliency, that provide you that availability, but it comes down to the mission in defining those metrics.
So now to just pull the thread a little bit more on disaster recovery, right? So no matter how many nines we're running in terms of availability and reliability, there's always that 1 in a million or 1 in a billion, right? So how does cloud, the nature of cloud, allow us to recover when something does happen on that 1 in a billion chance?
I can talk to that. So from a reliability and disaster recovery, you're allowed to or able to plan both at an enterprise level or even at an application level. Samir mentioned that it depends kind of on the SLAs and SLOs that an application may have. So if I have an application that is mission specific and sensitive where I need, 5 nines of availability or whatever, what I can do from an architectural standpoint is I can architect a high availability design to leverage cloud service providers' various regions. So most of your cloud service providers have multiple regions, meaning that I have data centers in the East Coast, the West Coast, across the United States. And so from an architectural standpoint, when I'm designing my application, understanding where my actual customers are, I can center those to one of those regions to automatically come up. I can do things such as load balancing, where I can have it running in multiple regions, pointing to a single perspective and drawn from there. Another thing that's also available from a cloud perspective is this concept of availability zones. Availability zones means that I have multiple data centers in a geographically region. So like here on the East Coast, I may have 3 or 4 different data centers here. West Coast, I may have 3 or 4. So from a reliability perspective and a disaster recovery, if I had a failure in either area, it's very easily transferred to the other one, and that's done through our architecture. And most often it's done automatically using thresholds and things of that nature. So it's up almost 100% of the time.
Thank you very much. So let's shift over to, I think, the natural next conversation is about performance, right? So performance, when we start to deal with cloud computing, right, the traditional NAS system is generally run from a rack of servers in the basement, many racks of servers in the basement, so to speak. And so all the infrastructure is right there, so nobody worries about latency, right? So let's talk a little bit about latency with the cloud. How does cloud ensure that the system performance is there, given that generally the equipment is not on premise and that information could be moving around from zone to zone, right, depending on how you've architected it? Do you want to start, Lane?
Yeah, so you heard Samir mention about the SLOs and things of that. So depending on the application's needs, they can design from an architectural standpoint, again, touching on the multi-regions and multi-availability zones, determining if you need, let's say, the 5 nines. Most often you can actually get that with just a single area, not necessarily going east to west. But if there is the need, you can actually architect it so that you're using those multiple regions to kind of get that performance metric to ensure the reliability. Additionally, most of your cloud service providers have native tools, and I mentioned triggers and alerts. So you can set up something where it's monitoring your application and a trigger. Let's say that you're seeing a CPU is reaching 85% or some number, you can actually set up a trigger so that it will auto scale, meaning that it'll stand up additional resources to ensure that your application continues to run. And then similarly, looking at the various regions, you can do the same thing so that if I saw that, let's say we had a network outage somewhere on the East Coast or something like that, we could transfer the traffic and everything to point to the West Coast so that we automatically have that system up and ensure 100% for the application and the agency.
So it's effectively seamless, right, to the user. But is there not a latency concern if, say, the users on the East Coast, the scenario you just played out requires a shift from East Coast to West Coast? There's signal in space-time, right? That's right. Is that a concern, or is that something that is also managed by architecture?
It's always a concern. It's minimal, and it is controlled by architecture. So when we talk about the cloud service providers in their regions, behind the scenes, they actually have infrastructure backplanes that they actually have their own networks, so that in the event they had an outage, East Coast, West Coast, wherever it may be, the traffic is actually operating on their backplane. And so for us as a consumer of it, it actually is seamless to it. There is a little bit increase, obviously, distance between East and West Coast kind of thing. You'll always see a little bit, but it is minimal. I can tell you that we test that out, and most agencies do, as part of the annual assessments of testing out kind of those latencies and that disaster recovery. It's very minimal and seamless to our application users.
Awesome. Samir, anything to add?
The only thing I want to add to what Lane just mentioned is that cloud is a utility. It is a service like you buy gas and electricity and water. And so you can use cloud to meet and beat your latency requirements. Most cloud services have a millisecond or even less than that sub-millisecond latency. So, the end user of the application, the mission systems are never going to notice that. And like Lane mentioned, there are many tools, there are many approaches to monitoring, building, and designing your system so that they could meet those objectives, those service level requirements for latency.
Great. Thank you guys both for that. So now let's get to, so we've established that high performance is not only possible, high performance is normal, and that architecture has a lot to do with that. But there will always be, and probably at multiple levels, right, a monitor and control function, right, a monitor and control requirement, which also will look different with cloud computing than it does, again, with the proverbial racks in the basement, right? So given that you're not buying massive physical infrastructure to own on a premises with cloud, so how does the cost piece affect the initial investment and the troublesome maintenance lifecycle, and how does that play into the monitor and control piece of the performance management?
So when we talk about monitoring and looking at the cloud, we look at it from a couple of different, actually a few different areas. One, you have your security monitoring. So going back to earlier about security and privacy and such, again, that is a major concern, obviously with executive orders and things of that nature, compliance with the latest NIST standards and government controls, all of that comes into play there. And most of those are actually, all of the cloud service providers have native tools, cloud native tools for security monitoring as well as performance monitoring. So you can look at the infrastructure, but as we mentioned earlier, with a public cloud, you're buying on-demand resources. So it's the cloud service provider's responsibility to make sure that they've got that infrastructure. Where a customer needs to worry is the application level, so the application performance monitoring. And there are tools out there and other software, there's third-party vendors and things like that. If you want to get a little bit more granular, looking at how your application is performing, going beyond just the old compute and storage concepts. And then there's a third one that we need to talk about from a monitoring perspective called FinOps, or financial operations. And that's all around kind of monitoring your costs in the cloud and ensuring that you're not overspending and helping kind of cut those costs. And I'll let Samir kind of touch on that for here.
Okay, great.
So yeah, I just want to pull the thread on FinOps that Lane was sort of alluding to earlier. FinOps is almost a life cycle approach on trying to forecast your costs properly, accurately, as much as one can, knowing that cloud is a utility, monitoring them, but then also ensuring that the monthly bill that comes has got some sense to it. These days, when it comes to paying your utility bill, the first thing you see is a lot of charges that you don't understand. And so I think the practice of FinOps has made us intelligent to provide that level of transparency to our customers on, firstly, what is it that they're paying and how much is it that they're paying for those different resources, knowing that there are multitudes of resources that they could be consuming in the cloud in any given month or any given day. Next, what we do is that we look at monitoring that and also trying to establish a system of tags or a taxonomy of tags where those infrastructure elements are being tagged so that they could be monitored. They could be held to budgets. If there's a certain spend limit, like Lane was alluding to earlier, that there's some sort of a monitor, there's some sort of an alarm. And then the last piece to FinOps is sort of really rounding that equation on forecasting the future. Knowing that budgets are tight, knowing that you could be overspending when it comes to even some of the newer technologies and using Gen AI and whatnot. A lot of these models are running in the background. You could be having large bills if you don't contain them. So it's really containing costs, forecasting costs, and it's also monitoring costs.
Right. And you mentioned that there are tools that allow you to monitor as you go. I assume the same tools will allow you or allow the system to learn as you go, right, in terms of what's being used, how much is being used, and so forth, right? So you can't, obviously you can't set something up where the air traffic control system has hit its spend limit, and so, oops, we're gonna turn everything off now because we don't have any more cloud subscription this month, right? So that's not how it plays out.
We would almost take the proactive approach, and maybe 6 to 9 months before that threshold, we would start planning procedures and design elements and even elasticity into the cloud infrastructure so that those events are prevented.
Right, and that provides an interesting opportunity, I think, as well for federal clients, and we'll talk a little bit more about that here in a while. But your typical federal waterfall program, right? You're predicting out your maintenance costs decades out, right? And that's all but impossible with the systems the way that they're designed today. Cloud provides you an opportunity to again, on demand, right? So you pay for what you use to some extent, and I think that changes the way that you need to look at maintenance budgeting planning, right, as you move forward too. But I think it's all going to take some learning, right? And so we'll just have to work together as a community to figure that out. So can I pull the thread on just some other terms that we talked about here, because I think it affects the FinOps and I think it affects performance management. So public versus private, or I guess in the case of the government, right, it's public cloud and you have government cloud, right? And then you also have a scenario where cloud can be on premises, right? Or some of the cloud computing and infrastructure can be on premises. Can we talk a little bit about sort of just those terminologies to help people equate them to the way that we do things today?
Yeah, so when we talk about the public cloud, and your terms, public and government, we're really talking about different regions. So what that means is, as a cloud service provider, if I use the term public cloud, it means that on the underlying infrastructure, the compute and storage, my neighbor who is sharing that same infrastructure might be a bank or somebody like that. Whereas if we're talking about a government region, it's only government agencies. That is your partner, or that's who's on the same underlying infrastructure rather than someone else. From a security perspective and stuff, all of the technologies and things are pretty much the same. It's just who's on the underlying infrastructure with you. And what were some of the other ones?
To just kind of clarify what we mean when we say like on premises.
So on premises means that you as a consumer or agency are actually still buying the infrastructure yourself. So you're still responsible for the actual hardware and hosting it in a data center and standing it up. How you divvy up the components of that infrastructure is up to you. There's more flexibility, and the idea is that you have more control, whereas in a public cloud, where you're using a cloud service provider, all of that is done for you, and it's kind of out of sight, out of mind. You don't have to worry about it. And again, one of the things from an agency perspective that's nice with the cloud service providers and using on-demand is that they're responsible for handling all of that security and the data privacy and things of that nature up to a certain point. So there's a shared model, if you will, where they're handling the infrastructure, and then the data and the configurations, the applications, you as a consumer are responsible for doing.
Okay, excellent. And I love the analogy of looking at cloud as a utility from this perspective. So anything else on this subject before we move on? We good, guys? Okay. So, all right, so now that we've got our audience on board with the new way of developing, deploying, and maintaining capabilities, so it's time to transition, right? And there's a technical and an operational piece of that. What are the key considerations when it comes to transition from legacy systems, the way that they exist today, the way that they're built, the way that they're maintained, to a new world where you're using some level, some type, some flavor of cloud computing? And with that, are there proven approaches related to change management? Because there's a people level component of this as well. It's not just technology and operations, right? So you want to go first, Lane?
Yeah, so from a migration standpoint and a process standpoint, when we talk about change management and considerations, it's really not that much different than previously when you're designing a new application. Now, there were a few terms that Samir had mentioned around containers and microservices versus this monolithic idea of what we call the lift and shift, the old adage of lift and shift, meaning that I have an application that's been running on-prem for however many years. I need to get it into the cloud, or I want to get it into the cloud. Let's just take it as it is and try to force it in there. That is one way, but we're finding that it's a little more costly, a little more time consuming, because as you are moving kind of some older technologies, maybe some older programming language and things like that, they might not easily go into the cloud just with the newer technologies. As such, the idea is that you're kind of breaking those down into smaller components. We mentioned containers. A container is a self-contained unit, a very minimized operating system with all the libraries and stuff from a software package perspective that is more agnostic, can kind of go anywhere. And then even more so, we have the microservices, where I had this old application that I was running. I now break it down into its certain components. It's taking input, it's doing output, those kinds of things. And now I break it down into what they call a microservice, meaning that they operate independent of one another with their own development teams. Makes things a lot easier to actually get into. And as far as modernizing an application into the cloud, that seems to be the way things are going. And it's just a more cost-effective way. And it's also easier to isolate it and troubleshoot issues during the development process.
Awesome. Samir, you have anything to add on that piece?
I would just like to say two things. When it comes to application modernization, there's a thoughtful approach that is taken to assess, plan, sort of migrate the way that best fits your agency's requirements, and then modernize. In some cases, the lift and shift is good. In some cases, it's good to re-architect. Mm-hmm. It's sort of rethinking what your system needs to do, and trying to identify those gaps and really plan it in a way that the design architecture is really something that's sustainable for the future. But the second thing I'd like to say is, it's essential to not only follow these methodologies and approaches, but also invest the time in really training and uplifting sort of your workforce in cloud technologies. There's several options available. There's multitudes of tools available, and it's always good to invest in teaching and educating and certifying your workforce on cloud before moving to the cloud.
Mm-hmm. Absolutely, I agree with that 100%. So pull the thread real quick on lift and shift, which is a term I just think is fun to say. So I worked on a program years ago where there was this natural, obvious tendency of, well, we're going to reuse, right? So we're going to build a new system, but we're going to reuse this code from a bunch of old systems. And the natural tendency was, well, that's great. We're going to save a whole bunch of money and time because we're just going to take this code and we're going to move it over here, right? And so integrating those multiple pieces of legacy code proved interesting. But you also, in hindsight, you kind of lose the ability to take advantage of new tools, right, that you could use in terms of the design and the development of code, new design processes, and so forth. And so I can see lift and shift being something you would want to consider, but I can also see that there would be value in making sure that although when you're bringing a capability to a new platform, you're also bringing it with modern tools and processes that go with it, which comes with training and change management and so forth. So thank you guys, I appreciate that. So to kind of wrap us up here, this is new to this industry to a great extent from an air traffic management perspective, but so GDIT has successfully migrated complex, large-scale, mission-critical capabilities in the cloud. Samir, can you give us a couple quick examples of where we've done that and what's worked?
So obviously, over the years, we've worked on many such modernization projects and efforts in the cloud, but I'll give two examples. One is a large defense customer, and their objective and mission was to deliver capabilities at a rapid pace, at a rapid clip. And it was important for them to modernize their infrastructure, use cloud services. You know, we've talked about microservices and containers. It was important for them to use all those components, but at the same time, have multiple teams deliver that code so that they could have their approving authorities certify and compliance folks certify their code so that when used in the cloud, it would support their mission. And we're talking about delivering code multiple times a day. So this was at a very rapid clip, rapid pace, and cloud really enabled their mission to success. We had all kinds of efficiencies. We even saved the agency a lot of money, and their mission was taking this time to market. So that was the key goal that was successfully achieved. The second example comes more on the learning front. So I want to kind of pivot gears on, cloud could be a daunting task if you've heard these terms for the first time, even though they've been around for more than a decade. So these are not new things, but sometimes it can be a bit daunting. And I remember this was a bunch of years ago in the summer, and we were trying to really understand how best to inject that learning, really create that culture, if you will. Because again, it's not easy to just put people in front of books or the learning modules and just say learn. You have to bring about that as a learning culture. And one of the innovative ideas we had was, this was with a healthcare customer, a very large enterprise healthcare customer, was to come up with a book club. A lot of these ideas of being agile and working collaboratively together and coming up with these service-based architectures and having people sort of work in unison on these different services and capabilities requires coordination more than just a project manager. It requires technical and technological know-how. And so we came up with this concept of a book club that would actually embody some of these ideas and views, where people could come together within a week or so on a cadence where they could review their lessons learned. They could review these best practices and share them across the team. And that sort of helped us build that culture to be agile in order to really adopt cloud for what it's worth.
Excellent. Well, thank you both very much. And thank you to ADCA for giving us the opportunity to hopefully provide some insight into some folks that they didn't have before. We hope you all enjoyed this session. The key takeaway here is that there's a clear role for cloud computing in the air traffic management mission space. But just like any other solution, it's not one size fits all, nor is it always the best solution, but should always be considered as a viable alternative. And decisions should be made based on sound technical, operational, and financial analyses. Our industry has been through significant technological changes like this before. GDIT has played a key role in many of them. But when managed properly, we believe the sky is the limit for cloud and the NAS. Sorry for the bad pun. Back to you, Rugger.
Thanks, Michael. We'll wrap up this year's webinars on December 11th with Pure Storage. Their topic, building a future-ready, scalable data platform for mission success. Don't forget to donate to ATCA Scholarship Fund. The Donate and Get Involved tab takes you to a QR code to make tax-deductible contributions. Again, we want to thank Michael Hawthorne and the team at GDIT for championing today's topic. Join us in 2025 as ACCA elevates its events and brings you Empower Her in Dallas on March 4th through 6th, the Tech Symposium in Atlantic City on April 29th and 30th, ACCA Connect in Charleston, South Carolina on September 29th and October 1st, and as we look forward to having you join us as we expand our offerings and benefits to your membership. Have a great day.